So today, we're going to pull back the curtain on the secret blueprint for all software. It's this universal language that's used to design these incredibly powerful programs, and it all happens way before anyone even thinks about writing a single line of code.
Let's just dive right in, because it all boils down to this one big question. How in the world do you take an idea from your brain, something kind of abstract, and turn it into a set of perfectly logical, structured instructions that a machine can follow, flawlessly, every single time?
All right, here's how we're going to break it all down. We're going to go from the basic idea to the final instruction. We'll talk about something called an algorithm, think of it as a recipe, then visualize it with a flowchart, build with some logic blocks, and finally wrap up with why this whole planning thing is such a big deal.
First up, let's kick things off with the big picture. This is the high-level process that pretty much every developer follows to solve any problem with a computer.
And right away, you'll probably notice what's missing from the top of the list: writing code. That's right. Before you even think about programming, you need a rock-solid plan. These 5 steps, from analyzing the problem all the way to testing, they're the universal framework that makes sure you're actually building the right thing.
Okay, so let's zoom in on what's really the heart of that plan. It all starts with creating a recipe, or what in the programming world we call an algorithm.
I know algorithm can sound kind of intimidating, but really it's nothing more than a super clear step-by-step list of instructions, all written in plain language. Seriously, if you can write down the recipe for baking a cake, you can write an algorithm. It's that simple.
And check this out. Here's a perfect, simple example. If you want to figure out how many books are left in a library, the algorithm is just these 4 logical steps. See? No guesswork, no confusion. Just a clear, straight path from the problem to the answer.
Okay, so writing it down is great, but what if you want to actually see the logic, to see how it flows? Well, that's where the flowchart comes in. Think of it as the architectural blueprint for our recipe.
Honestly, the best way to think about a flowchart is like those instruction manuals you get from IKEA. It doesn't need a specific language. It just uses these simple, universal shapes all connected by lines to show you exactly how to get from step A to step B to step C.
And these shapes, well, they're basically our visual dictionary. Every single one has a very specific job. Ovals are for starting and stopping. Rectangles are where the work gets done. And that diamond? Oh, that's where the real magic happens. That's where our program gets to make decisions. All right, so we've got our shapes, our building blocks. Let's actually start putting them together and see how they create different kinds of logic, starting with the most basic one of all.
You know, the simplest kind of flowchart is literally just a straight line. One thing happens, then the next thing, then the next, in a totally predictable order. That library algorithm we talked about, it would look exactly like this. Just a simple top-to-bottom flow.
But let's be real, life is rarely a straight line, right? Programs have to make choices. And for that, we use a branch chart. This is where we bring in that super powerful diamond shape we saw, and it's where a program really starts to feel like it's, thinking.
And this right here is the perfect way to see it in action. That diamond forces a choice. It asks a simple true or false question. Is this number x greater than or equal to 0? If the answer is true, the logic goes one way. If it's false, it goes a completely different way. And that single fork in the road, believe it or not, that's the foundation for all decision-making in software. Pretty wild. Okay, but now for the real game changer, repetition. I mean, what if we need to do the same thing over and over and over again? You're not going to write the same instruction 1,000 times, right? No way. You use a loop.
And there are basically 2 main flavors for how you can draw these loops. You've got the compact, all-in-one, conventional form, and then the more broken down, step-by-step, general form. You can think of it like shorthand versus the longhand version. They both get the job done.
But this is where things get really interesting. We can actually take this idea and nest it. We can put loops inside of other loops. This is how you tackle these ridiculously complex, layered problems with a logic that's, well, actually surprisingly simple and elegant. Want a perfect everyday example? A digital clock. Think about it. There's a super fast seconds loop that runs 60 times. As soon as it finishes a full cycle, the minutes loop ticks over just once. And when that loop runs 60 times, the hours loop finally ticks over. It's this beautiful nested system, and it's running on your wrist right now. Okay, so after seeing all that, you might be thinking, why bother?
right? Why go through all this trouble of making algorithms and drawing flowcharts when you could just jump straight into the code?
Well, because this whole planning phase is, and I'm not exaggerating, absolutely crucial. It forces you to get your logic straight. It lets you break down these massive, scary problems into small, manageable pieces. It helps you find errors on paper, which is way cheaper and faster than finding them in code. And maybe the best part? A good flowchart can be turned into any programming language. You know, this quote just hits the nail on the head. These blueprints, the algorithm and the flowchart, they're that vital bridge that takes you from a tricky, messy problem all the way to a clean, functional, and working program.
So, let me leave you with a little challenge. Think about your morning routine, making coffee, the commute to work. What decisions do you make? What parts do you repeat every single day? Try it. Could you actually draw it out as a flowchart? Once you start seeing the world this way, you start to see the secret logic that's hiding in just about everything.